Okay, find the range. Find the range of values of x which 3x is less than or equal to x plus 6 and 2x plus 4 is less than 3x plus 6. Okay, now this is the problem that we have got to answer. And you can note that we are having two inequalities. This is the first one, and then we also have this one. Now, to find the solution to simultaneous linear inequalities, it actually means that we are going to find the solutions that satisfy both inequalities. And to do that, we are going to first of all solve each inequality at a go. So it means that our step one will be that, let us begin with this inequality. So we are having 3x is less than or equal x plus 6. So we say that we have 3x. Now we will bring this x to come this side. So it will be minus x. Okay, this is less than or equal to 6. Now 3x minus x, we will get 2x, which is less than or equal to 6. Now we will divide on both sides by 2, and you find that 6 divided by 2, you get 3. So our answer will be that x is less than or equal to 3. Now, this is our first inequality. And note that I've told you already that if I have x is less than or equal to 3, this is the same as 3 is more than or equal to x. Those two inequalities, they are the same. Now, let us solve another inequality. Okay. So let's solve this inequality. So we are having 2x plus 4 is less than 3x plus 6. So we are going to bring this 3x to come this side, and then we will take 4 to go this side. So it means that we are going to have 2x minus 3x is less than 6 minus 4. Is that okay? So
Yes.
you see that 2x minus 3x, we get negative x, which is less than 6 minus 4, which is 2. Now, we get minus x divided by minus 1. And because we are dividing by minus 1 on both sides, this sign will reverse. it is less than, now it will be more than. So it means that x is more than -2. Okay, now that we have finished solving the second inequality, we are going to show this on the number line. Okay, actually this is also, we can also write it as -2 is less than x. Okay, now let us see how to show this on a number line. Let's have the number line. Okay.
Okay, thank you, Mayor. Okay,
so then let's have, let's say this is 0, and then we have 1, 2, 3, 4, 5. Then let's have -1, -2, -3, and -4. Is that okay, student?
Yes.
Okay. Now, let us show x is less than or equal to 3. So it means that I will go at 3, I use closed circle, then I go to the left. Okay. Now, when I finish that, I will come and show x is more than -2. So I will go at -2, then I use open circle. Then I go to the right. Okay. Is that okay, student? Okay. Now, you see that this part and this part, they overlap. The number line going to the left overlaps with the number line going to the right. So, let us try to color this part. Now, this part where there is overlap, it is where we have solutions to both inequalities. It implies that 3 makes this inequality and this inequality true. Even 2 makes this inequality true. Even 1, 0, -1, but -2, we do not include it because you can see this is an open circle. So -2 is not a solution, but the solutions are the ones that are within this overlapped part. Is that okay, student? Do you understand? Okay. So now remember the question says that we get the range of values. The range of values. Now let us show the range. The range will be that I have x is more than negative 2. Remember, I told you that x is more than negative 2 is the same as negative 2 is less than x. So I say that negative 2 is less than x. Then I have this x is less than or equal to negative 3. So I say this x is less than or equal to 3. So this is what we call the range of values. Do you understand, student? Okay. Now, when we say that the solutions to these two simultaneous linear inequalities, we mean the values that are within this range. For example, -1, 0, 1, 2, and 3. But also don't forget that the decimals also their solutions. For example, here if you have 2.5 is okay, 1.5 is okay, 0.5 okay, negative 0.5 okay. So also the points that are between these values are the solutions. Okay, I hope that is okay. Now, let us look at another example. Let's have example number 2. Okay. Now, for this example, let's find the range of values of x for which for which 2x minus 3 is less than or equal to 7 and 2x plus 1 is more than negative 3x minus 4. We have 2x minus 3 is less than or equal to 7 and 2x plus 1 is more than negative 3x minus 4. Now, this is the range of values that we are going to find. Okay, like we have seen already, our step 1 will be solving these two inequalities separately. So we start with this one. Let us have 2x minus 3 is less than or equal to 7. Now we will have this minus 3 will go this side. So we have 2x is less than or equal to 7 plus 3. Then we will have 2x is less than or equal to 10. On both sides, we divide by 2 so that this will be 1 and here we get 5. So it means that x is less than or equal to 5. Is that okay?
Okay.
Okay.
Okay. Now, in the next step, we will solve the second inequality, which is this one. So we are going to have 2x plus 1 is more than minus 3x minus 4. So for this time, we will bring minus 3x this side, and then we take 1 this side. So then we will have 2x plus 3x is more than negative 4 minus 1. So then 2x plus 3x, it will be 5x, which is more than negative 5. So we will divide on both sides by positive 5. Remember, when we divide by a positive, no worries, because the inequality will not reverse. So we get 1. Okay. Here we will get minus 1. So it means that x is more than negative 1. Okay. So now that we have got the solutions to both inequalities, we are going to show this on the number line so that we can get the range of values. So in our next step, we are going to show this on the number line. Remember, this is the first step. This is the first step. This is the second step. And our third step will be to show this on the number line. Okay. Now, let us draw the number line. Okay. So let's call this let's call this 0. We have 1, we have 2, we have 3, we have 4, we have 5, we have 6. This side, let's have negative 1, negative 2, and negative 3. So let us show the first inequality. The first one, we have got x is less than 5. X is less than 5. So we go at 5. Yes, x is less than or equal to 5. So we will go at 5. We use closed circle. Okay. Then we go to the left. Okay. Now, after that, we show the second inequality, this one. So we will go at negative 1, which is this one. Because we have more than, we are going to use an open circle. Open circle, and then we go to the right. Okay. Now, let's show the range. The range begins from the area of overlap here and here. So let's color this part. Okay. Now, it means that the solutions to this inequality, they begin from 5, 4, 3, 2, 1, 0. But because this is open circle, negative 1 is not a solution. But don't forget that also the points, the decimal numbers, are also the solutions. For example, we have, let's say, 4.5, we have 3.5, we have 2.5, we have 1.5, 0.5, negative 0.5. they are also the solutions. Now, let us show the range of values of x. Now, it is always better to start with a negative or to start with the smallest solution in case you have. So since we have x is more than -1, remember this is the same as -1 is less than x. Okay? So I will write that as -1 is less than x. Then I have this, which is x is less than or equal to 5. Now I will continue and say this same x is less than or equal to 5. So that is the range of solutions. Do you understand that, student?
Yes.
Okay, so it means that the solutions, they begin from, let's say, minus 0.5, they move up to 5. So those solutions, they make this inequality true, and again, they make this inequality true. So that's why we call them solutions to simultaneous linear inequalities.